So theoretically, in 20 seconds, something should happen. Oh, I'm gonna like do not disturb mode this.
Do you mind if I check to see if I can find it?
Go for it. Excellent. Okay.
Cool. Yeah, that's all I can do from here. Usually, if it comes up, mine at least it gives me an option of when to update. So
it like got weird. Hold on.
Do you want water or anything?
What's happening?
Surprised if there's only 6 people on.
Do you want to mute that so it doesn't? Hey everyone, for those of you already logged on, we just started the stream a little early to make sure that all of our tech works. So we're gonna wait and start probably a couple minutes after 10:30, so that everyone has a chance to join. Welcome. Hey everyone, so we're up to about 50 people watching. We're expecting about 100 or so. So we're just gonna wait a few minutes to get started. We'll probably start it in like 5 minutes maybe, just to make sure that everyone has a chance to join, especially for the first day. So welcome everyone who's joined, and yeah. So right now we're at about 85 people streaming, so we'll just wait a couple more minutes, and hope that we get a few more people joining in. But also, especially because it's the first day, if you are watching this after the fact, because you had some tech issues and couldn't log in, that's totally fine, don't worry about it.
And if you're not already, please also log into the Zoom so that we can put you in breakout rooms with everyone.
How many people are in the Zoom right now? 50. Okay. Okay, let's actually start at 10:40. I don't know if other people have told you this, but often in-person classes at Berkeley start on what we call Berkeley time, which is 10 minutes after whatever the scheduled time is. So you have a class from 9 to 10 and 10 to 11. The class from 9 to 10 would actually end right at 10, and the class from 10 to 11 would start at 10 after 10. So we had been planning with virtual to start at 10:30, and I think we would like to on future days. So if you can show up right at 10:30, that would be best, unless you can't, in which case tell us and we are flexible. But for today, just so that we can make sure that everyone's on the same page and is here at the beginning, we'll wait and start right at 10:40. How many people are in the Zoom?
83.
Okay, so right now we have about 10 more people on the YouTube Live versus what we have on the Zoom. So we would really like, ideally, for everyone to be both watching the YouTube live stream and in the Zoom, so that you can have small group discussions using Zoom. So if you are currently on YouTube and not on Zoom, please also log into the Zoom call. You should have gotten a B Courses announcement this morning, and you can look on B Courses for instructions on how to do that. That said, of course, if there are tech issues and you can only be on the YouTube, that's fine, but ideally reach out to us so that we can try to help you resolve that so you can be on Zoom in the future. Those of you who are having trouble hearing the live stream, this is probably obvious, but make sure that it is unmuted. So in the bottom left next to the pause, just make sure you've adjusted the volume within YouTube so that you can hear it. Yeah. I'm glad that at least some of you can hear it. Okay, so it is 10:40, so let's go ahead and get started. When I post this video, so you'll be able to watch the videos after the fact, also on the same YouTube channel. I'll edit out all of that blank space at the beginning. So if you are one of the about 10 people who's not currently streaming but is in the course, and you are having tech issues this morning and that's why you weren't able to stream, don't worry about it. We will always make sure that you have all of the materials that you can watch later if you need to. Okay, so this is day one of prep chemistry. We wanted to start by just introducing ourselves, so you have a bit of an idea about our background. So I'll go first. I'm Lorena. I'm originally from Ohio. I grew up in Ohio. I graduated from Princeton Chemical Engineering in 2017. So that was my undergrad. And now I am going into my fourth year as a PhD student in chemical engineering here at Berkeley. Also, just wanted to say, please call us by our first names. I'm not a professor. I'm not yet a doctor. I will be in a couple years. And when people call me Miss Grundy, I feel old. So please call me Lorena. Please call Katie, Katie. That will be true for all of your GSIs at Berkeley, unless they tell you otherwise, but for the most part. I wanted to give you a little bit of background on my research. So I study polymers. So polymers are long chains of repeating units. So you can think of these as beads on a string. And those beads have different chemical structures. And we'll get a little bit into the nomenclature and what those chemical structures can potentially look like. But I study these polymer chains, and I mix those polymers with a salt. And any salt is a combination of positively and negatively charged ions. And when you make that mixture, it's called an electrolyte. And the way that a battery works is we put two electrodes on either side of that electrolyte. And when we actually use our electrolyte to power our phone or our car or whatever we're using with our battery, those ions need to move throughout the electrolyte. And so what I study is how does the chemical structure of that polymer affect how the salt moves. So if our polymer is purely made up of carbon and hydrogen, those ions might move really slowly. And if they move really slowly, then our battery charges really slowly, right? So the point of my research is trying to make electrolytes for batteries which are safe, but which allow our batteries to be high performance, charging quickly, etc. And if anyone wants to learn more about my research in general, I'm happy to talk about that offline. And then outside of science, I really like hiking. One of the things that I really love about being in Berkeley is that we're really close to a lot of beautiful hiking areas nearby. So that's what I like to do in my free time.
Okay. Hi everyone, I'm Katie. So I grew up in Delaware, and I went to the University of Delaware and got my degree in chemical engineering back in 2017. So like Lorena, I'm a fourth year PhD student in the chemical engineering program here at Berkeley. And in my free time, I also enjoy a lot of hiking and outdoors activities too. That's one of the reasons I wanted to move all the way out to California from Delaware. So here in this picture is me doing a hike in the Grand Teton National Park with my brother and sister. I'm actually an identical twin, so my twin, who's on the left, also got her degree in chemical engineering, but from Virginia Tech. And for my research, I work on a technique called nuclear magnetic resonance. So what that is it kind of takes advantage of the different spins of nuclei and uses that as a tool to study materials. So then at the end of the day, I study how materials work using this method. So throughout this course, we'll touch on some of those concepts that kind of relate to this technique, but I'm also happy to chat if anyone has any questions.
Cool, so I'm seeing a lot of tech questions in the Zoom group chat, so maybe we should have done this before introducing ourselves, but I'm just going to go through some very basics of what you need for how to use YouTube and how to use Zoom. So when you first log into YouTube, this is an example of a different stream. So the things you need to know on YouTube are on the bottom left, there's pause and volume. So those of you who are having difficulty hearing, make sure you're not muted. Make sure that volume is up so you can hear us. And also make sure you're always live. there's the little settings icon in the bottom right of the video. You can adjust a lot of things, but one that might be relevant for those of you with poor internet access is the video quality. So if your internet is lagging, you can turn down the video quality. It'll be a little pixelated, but you'll at least be able to be watching live. And then the last thing for YouTube is the chat, which some of you are already using, which is great. That is the best way to ask us questions during the lecture. So please use that chat, ask us any questions, and we will do our best to respond, but also you all should feel free to respond as well, which you're already doing with questions about how to get on the Zoom and stuff like that. So please use the chat. Please feel free to do that. Because the YouTube is public, we can't make sure that only prep students are watching the Zoom. Or are watching the YouTube. So we'll do our best. If anyone puts like super trolly comments that are clearly not prep people, we'll do our best to delete them as quickly as possible. So then for Zoom, this is just an example of what a Zoom group would look like with a few people. The very first thing you need to know is in the bottom left of your window, there should be both a microphone and a video icon. Make sure that whenever you're not trying to speak, that microphone is muted. So if it looks like it does on this screen right now, you are not muted. And any sounds that you're making, the entire group can hear, and that can be super distracting. So everybody just take 1 second and check down at your microphone down there and make sure there's a nice red line through it that says that you're muted. Similarly, there's the video as well, so you can have your video either on or off. Ideally, we'd love you to have your video on as much as you can, but of course we recognize that everyone has bandwidth issues, so if you need to turn that video off, that's totally fine. Yeah. You also, if you don't want people to see the inside of your bedroom or wherever it is that you are, you can choose a virtual background and Zoom will automatically put like the Golden Gate Bridge or whatever behind you so that we can only see you. That's totally fine. Other things on Zoom, up in the top right, there's an option for gallery view or speaker view. And if you select gallery view, that lets you see a bunch of people's faces at one time instead of just like whoever's making the most noise in this moment. So I'd really recommend that you do that. And then the last thing is there's a Zoom chat in the bottom. So what we're really going to be using Zoom for once we get into the actual material is we're going to have you in small breakout rooms of about 5 people. And so what we envision you using Zoom for is you're in this small group, and if you're shy and you have a question but you don't want to ask it on the YouTube Live in front of all 100 people at once, you should be able to sort of say to your small group like, oh, are you also confused about this in the chat? And either someone can answer it or they can say, I'm also confused, we should ask that. You don't have to do that if you're not shy and you want to just ask it in the YouTube chat. Great, go for it. But we just thought that would help to give people sort of a smaller group. And then also we'll pretty frequently have you do practice questions in those small groups. So we won't have to like jump between breakout rooms and not breakout rooms. You'll just be in the breakout rooms constantly. But we do ask that while we are actively lecturing, you're not sort of distracting the people in your breakout room with like having, really loud off-topic conversations. So is there anything else you wanted to add about tech stuff?
So I just muted everyone in the Zoom call because there's a lot of background. So in the future, I'll do that at the start of every single class to kind of help with that issue. But that doesn't mean that you can't talk with each other. So feel free just to unmute and have a conversation. It's just simply so if people forget that that their audio is on, we don't get a lot of feedback. So thank you for bringing that up in the chat. I'll try to keep monitoring throughout the class so that we can kind of correct these in real time.
And it also will be much less of an issue once you're in breakout rooms because there won't be 100 people potentially unmuted. It'll be 5. So it should be more manageable. Cool.
Great. So we wanted to start off by discussing some of the goals of prep. So our main goal is to prepare you to succeed in Chem 1A. So Chem 1A is a general chemistry course here at Berkeley, but it does still assume quite a bit of knowledge from the fundamentals of chemistry, math, and physics. So what we want to do is kind of address some of the disparity in background people got coming from different high schools across the country. So we actually aren't assuming any background knowledge whatsoever for prep. So we do apologize for people that have taken like AP classes and things like that that kind of may have prepared them for this course. We will do our best to keep you interested, but just realize that we are teaching this course to try to bring everyone up to the same level. So there's maybe some parts that are slow for you, and feel free to reach out to us if you'd like to discuss more in-depth chemistry. We're happy to do that. So in our survey, we were able to get quite a bit of information about the chemistry experience you guys all have. So about 20% of you have actually taken an advanced chemistry course, and about 50% have taken a general chemistry course. So a lot of this could be review, but then there's still a sizable fraction that really don't have much chemistry experience at all. So we're really trying to make sure that we can reach everyone. So if you ever feel lost, please reach out. If you've never taken a chemistry course before, this probably will feel very fast for you, and we don't want anyone to be left behind. So we'll discuss some of the resources available later, but please take advantage of that and never feel afraid to reach out to us, the tutors, or any of your other classmates for more help. So unfortunately, everything is online this year, but please don't use that. Please make sure you still try to get to know everyone in the class. So these will all be your peers moving forward for your time at Berkeley, and it's really important to have people that you can ask questions for homework or study groups and things like that. So please do try to take the time to get to know people in your breakout rooms or throughout the program. That's one of the good things about the way we design this, is that we try to create sort of the small group atmosphere, even though there's 100 of you on Zoom right now. And everything this year is going to be quite different from how a normal college runs. So we're hoping that getting used to some of these like technology tools will kind of help you succeed in transitioning to kind of how classes at Berkeley are going to be run this fall.
And part of the reason, just to add, part of the reason we structured this course this way is that we talked to some of the people who are going to be managing the instruction of Chem 1A in the fall, and they're going to be doing it exactly the same way. So they're going to have a YouTube live stream with Zoom small breakout rooms. So part of why we did it this way is because we think it's a good idea, but another part of the reason that we did it is because this will be exactly how Chem will be for those of you who are taking Chem 1A in the fall.
So we just wanted to quickly go over the planned course schedule. So the first week covers a lot of basics. So for those of you that took AP Chemistry, this could be kind of the slow part, but this is really going to help us make sure that everyone has a solid background of some of the nomenclature and definitions that the rest of chemistry is built on. And then in weeks 2 and 3, we start talking about some more advanced topics like chemical reactions and other topics like that. And then at the end, we'll also give an introduction to some of the background knowledge that you'll need for Chemistry 1A. So the last few days are actually based off what you'll do in your first week of Chem 1A. And the idea is then that we can kind of introduce you to some of this material and some of the math and physics background that you'll actually need for the course so that you can jump right in and really have a strong start to Chem 1A.
Cool. So the course structure we've kind of touched on a little bit, but everything will be posted via B courses. As of earlier this morning, there were only like 2 people who weren't part of the B courses. So probably none of you are those people, otherwise I don't know how you got the link. But if you did somehow, please join the B courses. We'll be sending out all of our announcements, everything, all of the materials will be posted there. So it's really important that you be on the B courses. That's also going to be true for a lot of your classes at Berkeley. So get in the habit now, check those notification settings on B courses to make sure you're actually getting email notifications for the announcements. So yeah, the B courses page is like your home base for this class and for most of your classes at Berkeley. So make sure you're there. As you already know, because you're here, our lecture is in YouTube Live. That will be recorded, so that will be posted on my same YouTube channel, which you can subscribe to if you want. It's literally just this, so don't expect anything fun. But that will be recorded. So I'm not actually sure whether the chat gets saved permanently, but just sort of like be cognizant that what you put in the chat like might be visible later. But the Zoom breakout rooms will not be recorded. So you should feel free to have your video on or whatever, like no one else other than your breakout room will ever see that. But yeah, so all of those videos will be for the YouTube will stay on YouTube and you can watch them later. We'll keep them up kind of indefinitely, so if you're in Chem 1A 3 months from now and you have a question that we talked about in prep, those YouTube lectures will be there that you can use to review whenever you want. So as you probably know, there's no graded component to this course at all. No exams will be graded. There's no consequences for doing poorly on anything. So we hope that sort of makes you comfortable participating. There's nothing bad can happen to you in any way. But that said, we will have assignments that we'll post every day that we recommend you do for practice. And if you submit those assignments via B courses, we will provide feedback on them. So you don't have to, but we think that they're really good for practice. Only about half of you have a printer, which is fine. I don't have a printer. So we don't expect you to be able to print those assignments. But if you want to, you can. If you're someone who really likes to work on paper, you're totally welcome to. So every day in lecture, we'll have practice problems that we actually do together in our groups in lecture. And all of those problems are on the problem sets. So just by coming to lecture, you've already done half of the problem set. And then the other half will be extra practice problems that you can do at home by yourself for extra practice. And you just kind of have to manage your own time of, what do I feel I need the most practice in? If this is, super, super easy for you, whatever section we're on any given day, and you only want to do half the practice problems, sort of that's up to you. We recommend you do them for practice, but we really want this course to be whatever is most useful for you.
Okay, so then we also wanted to discuss some of the resources available so you can succeed in this class and then Chem 1A. So please ask me and Lorena any questions that you have, and we'll also stay after class to answer any questions. So what we'll do is we'll return to the Zoom room. So then if you have any questions that you want to ask us, just stay in that Zoom room after lecture has ended, and then we'll be able to talk to you more. And then also feel free to email us if you'd like to set up a separate time to talk about anything, really. We're happy to answer your questions about transitioning to college or picking majors, so it doesn't have to just be about some of the chemistry topics we have. So please feel free to contact us. And then also under B courses, there's a discussion section. So please also ask questions there, and that will allow everyone in the class to see it, just because chances are, if you have a question, someone else also has the same question, and that kind of allows everyone else to kind of have their questions answered at the same time.
And just to be clear with the B courses discussions, we won't be monitoring that live during class. So if you have a question like right now during class, post it in the YouTube chat or talk about it in your breakout rooms or the Zoom chat. We won't be monitoring the B courses discussion live. But if you're doing the practice problems tonight and you have a question, that's when you should use the B courses tab or email us or whatever you want.
Yeah, but try to use the discussions tab.
Yeah.
And then we have 3 tutors with us this year. So we have Caitlin, Zach, and Alex. So I believe Caitlin and Zach are both doing math as well, so you should see quite a bit of them. So feel free to also ask them questions as well, and they'll be holding office hours Monday through Wednesday, 8 to 10 p.m., and Thursday through Friday at 5 to 7. So all this information is also available in the syllabus online, so you should be able to check that too. And then also don't forget about each other. So please feel free to work with your classmates on assignments and also ask questions of each other. That really helps everyone learn too.
Cool. So the last thing I wanted to talk through is our course expectations. So one of the most important things is just how we treat each other. So we really want to treat each other with respect, and we want to be responsible with how we're communicating. So we want everything about prep to be non-competitive. Again, there's no grades, there's no reason for anything to be competitive. And hopefully the same will be true in a lot of your classes at Berkeley. It's really hard, I would say impossible, to get through all of your classes at Berkeley, like doing all the homeworks by yourself and never working with others. So you should really strive to collaborate with your friends. You'll need that to help you with some of the harder classes and harder problem sets. So on that note, we value each other's views and contributions. If someone says something that you think is wrong, just sort of engage with it and, oh, like, I disagree. I actually think the atomic number of hydrogen is 3. I don't know, whatever. But do so politely and professionally. And we already touched on this kind of at the beginning, but we need to recognize that we all have different backgrounds and specifically in the chem context, different levels of preparation for chemistry. So just think about, like, if something was really hard for you and someone in your breakout room was like, oh my God, this is so easy, why are we doing this? We all already know this, how that would make you feel. So if there's something that's really easy for you, awesome, like, congrats, you're super well prepared. Help your teammates through that, because I guarantee you there will be things that you're not as well prepared for that they're better prepared for and they can help you. So just really be cognizant that just because something's easy for you doesn't mean that it's easy for everyone. We expect you to be present and engaged every day, so that means actually having the YouTube live stream up and paying attention, and then participating in discussions in your breakout room when appropriate. That said, there's a global pandemic right now. You're all working from home, your internet might be unreliable, so this is not like a pressure thing. If something is going on with your family, if you get sick, if your internet goes out and you can't come any given day, that is fine. We want prep to be something that's helpful for you, not something that is an additional source of stress for you. So if there's anything you need from us, any resources you need, please just tell us. Anything that we can do, both logistically and with questions about chemistry. Both of us, learned this material in Intro to Chemistry like 6 years ago. So it's been kind of a long time for us since this was new to us. So we're obviously going to do our best to make sure that everything's clear, but we can't read minds. I'm sure there will be things that we say that are confusing. And we really need you and want you to tell us when something we say is confusing. It's not like a burden to ask us to explain something. By telling us you're confused, you are making this course better, because I guarantee you if you're confused, your peers are confused too. So I can't emphasize enough, like, please ask questions. Honestly, the saddest thing for me would be if someone at the end of this course was like, I was so lost the whole time. Because, like, I would have wanted to, help and make things clearer. So please ask questions. Please ask us if you need any help. And then the last thing is integrity. So you're not turning in anything for a grade here, but you obviously will be in the fall. And it's really important that you work with others, but that means actually working with others to understand what's going on and using their help to understand, but making sure that what you actually turn in is your own work. So not claiming others' work as your own, working with others, but making sure that by the time you actually turn it in, you didn't just copy what someone else did, you understood it. One thing I'm realizing that I forgot to say with the text section is that there is about a 20-second delay with YouTube versus Zoom. So can you mute everyone again? Yeah, cool. So I will see your YouTube chat live, but what you're actually hearing is what I said 20 seconds ago. So I will respond to what I hear on the chat, but you'll hear my response via Zoom, via YouTube, 15 to 20 seconds later. So just be patient because of that lag, And B, that means that when I say, are there any questions, I'm gonna have to pause for like 30 seconds, because even if you ask your question, right when I say, are there any questions, it'll take about 20 seconds for me to be able to respond. So I think that's the end of our sort of logistics and syllabus section. So if anyone has any questions on any of that, now would be a good time. I think we're also...
Yeah, so maybe we'll give you like 30 seconds to post any questions in the chat, and then what I'm going to do is I'm going to split you up into breakout rooms. So on your Zoom, you'll just see something that pops up that says that you're going to a breakout room, and you just need to click OK, and we should just be taking care of everything on our end.
But yeah, so now's that awkward 20-second lag where I wait to see if you have any questions. And no worries for those of you who were maybe new to Zoom and accidentally had yourselves unmuted. Honestly, like, everything in my professional life has been on Zoom for the last 4 months, and I still do it. There's a question in the chat that says, when is there a problem set due? So the first problem set is due tomorrow morning. We have the due dates set for 10:30 a.m. the next day. The first one is pretty short, just because we have less time during this first class because of all of this stuff that we've just done. So the first problem set is about 6 problems. We will do 3 of them together at the end of today. And, you know, we think that it would be wise for you to do the problem sets as they are due, but, you know, there can't be a late penalty when there's no points for anything. So if you don't have time to do it the night that it's assigned, but you still want to do it a couple days later and get feedback, feel free to submit it late. We'll still give you feedback. But yeah, there will be a problem set due every day. But like I said, we'll do half of the problems on that problem set in class, and it's kind of up to you which extra practice problems you think would be the most useful. We recommend that you try to do all of them, but it's up to you. Oh, if you already submitted it, like, that's fine. Totally not a problem. Yeah, so in future, if you do it ahead of time, you're making a little extra work for yourself just because you're doing problems by yourself that we're gonna do in lecture together. But if you wanna be like super on top of your game, and we'll try to have... So we posted this problem set a couple days ago. We haven't posted the one for tomorrow yet. We'll post it sometime this afternoon or this evening. So if you wanted to, you could download tomorrow's problem set tonight and start it. But just be aware that if you do that, we will do some of those problems together in lecture, and you might be a little bored or a little ahead and really on top of your game. So yeah, whatever you want to do. I think we are in the process of doing breakout rooms. So yeah, I think most of you are in breakout rooms, but about 30 of you aren't yet. So we're just finishing sorting those. So as a reminder, hopefully you'll be able to use those breakout rooms to sort of chat about questions. Ideally, while we are actually speaking and lecturing, you'll have yourselves muted so that everyone can hear us, but you can ask questions using that little chat box that you can find at the bottom. And then and you're welcome to have your video on the whole time if you would like. But then when we say, go work on this problem in your breakout rooms, then you can sort of turn the mic on, turn the video on, chat about it, talk for a while. Yeah.
Okay, so you guys should all be in breakout rooms at this point. So one thing that would be really helpful for us in the way we've organized this is if people go and create their Zoom accounts through Berkeley. So
Not necessarily right this second.
not right now, but after class, if you could all do that, because that will allow us to help pre-assign breakout rooms so that we don't have to click individually and assign you all one by one. So that will make things easier for us if everyone could just go and use their berkeley.edu address to sign up for an account.
For free.
Yeah, so no cost. It is something that you'll probably be required to do in the fall anyway for your classes. So it's really just getting a head start now to go ahead and create that account. Yeah. Great. So you should all be in breakout rooms. Please now at this point use the YouTube live stream to ask questions because not everything will come to the main chat through Zoom now.
Yeah, so right now if you use the Zoom chat, that chat will only go to your breakout room, which is great. You should have chats in your breakout room, but if you have questions to actually address to us, use the Zoom chat.
Right.
And if you have been invited to a Zoom breakout room, make sure you click the yes, go to this breakout room.
Yeah.
Cool.
Great. Okay, so first off, we wanted to discuss a little bit about what chemistry is and why engineers would need to study it. So chemistry is sort of broadly defined as the science of matter and the changes it can undergo. So here we sort of have the fun picture of just how different chemical reactions can work. But chemistry is a lot broader than just mixing a bunch of vials together. So a lot of you here are mechanical engineers or civil engineers or bio engineers, so I thought I'd do a quick example. So if you think of the Golden Gate Bridge, when people were designing this bridge, they probably asked themselves, what materials should I use to build a strong support for a bridge? And from a chemistry standpoint, what this question is basically asking is how does the chemical composition of the material I use affect the strength? So when they designed this bridge, they wanted it to be able to support a lot of load and for it to be very stable. So we know that bridges are made of steel. So in this case, steel is made of mostly iron, but actually on its own, iron is pretty weak. So in order to make it stronger, people changed the chemistry of this material by adding small amounts of carbon atoms into the iron. Just as a quick point, a lot of this is kind of simplified, so we'll learn later in the course about different metal bondings, but right now here this is just an illustration. So as you add more and more carbon, the strength of your steel increases. And this allows you to pick a material that can help you build a strong bridge that will allow it to exist safely for a long time. So that's kind of just one example of why someone that's like a civil or mechanical engineer would really need to understand chemistry. So when they go out into the field and make these design decisions, they have the background knowledge to be able to do that successfully. So that is just one quick example, but chemistry is important for a lot of disciplines. For example, in designing materials that go into outer space, it's really important to understand some of the chemical structures of these materials, because these materials are in really, really harsh environments. Or for those of you that are bioengineers, you may think a lot about how to design prosthetics that can last in the human body for a long time. And then if you're a civil engineer and are thinking about building various buildings, again, like the bridge example, these structures are still quite important. And then my fourth example is for water purification. So sort of along the environmental civil engineering aspect of things, you can think about how the different chemical structures of pollutants in water, how you can use that information to actually purify water to make it safe for people to drink. Great, so then
cool. So we just want to give you in your breakout rooms just a quick 5-minute break. We know that having a lecture for over an hour can be kind of long. So go ahead and take a 5-minute break. You can go to the bathroom, whatever you want, get a snack, or just chat and get to know your breakout room. So we're going to keep you in the same breakout rooms for the rest of this week is the plan. So get to know these people. You're going to be working with them both later in this lecture, but also for the rest of the week. So go ahead and just take that 5-minute break. Okay, so let's go ahead and come back together. I'll give you like 30 seconds to finish your conversation, especially because of the lag. But yeah, let's come back together. Okay, so like Katie mentioned when we were talking about why we should study chemistry, chemistry is really the study of transformations of matter. So we want to learn about the properties of matter and also the transformations of matter from one form to another. So that is what a reaction is matter changing forms. Like we said, we're really going to start from the ground up. We're going to go a little quickly through the beginning, but we really don't want to assume any chemistry knowledge. So even if you already like totally know what matter is and states of matter and everything like that, we really just want to set your foundations really strong. So things will get a little more in depth into atoms and bonds and reactions later, but we wanted to just start with the very foundations of what chemistry is, which is working with matter. So matter is anything that has mass and takes up space. So that is everything that you can see, pretty much. So your computer, your watch, anything. A substance is a word for a pure form of matter. So your computer has plastic and metal and all sorts of stuff in it. So it is not a pure form of matter. Whereas if you had like perfectly purified glass of water, that water would be a pure substance. So just for practice, in your small breakout rooms, I have a list of things here. So air, a block of gold, a $5 bill, capitalism, seawater, chemistry, a diamond, and a diamond ring. And take a few minutes and discuss which of these things you think are pure substances, which you think are matter, and which are matter but not pure substances, and then which you think are not matter at all. So go ahead and unmute yourselves, turn your videos on if you can, and just discuss how you would classify these various things. Probably enough time. Can someone, if you think your breakout room needs more time, can someone send a quick message to the chat? And if not, we will keep going. Cool. I am not seeing any messages in the chat. So what I would say is that the only two things here that are pure substances are a block of gold and a diamond. So gold is an element and diamond is a carbon structure. They're not like a mixture of anything else. You could make an argument that there might be impurities in there, but in general, if those things are, as we're defining them, they should be pure substances. Things that are matter but not pure substances. Oh, someone said they needed more time. Yes, this is the problem with the lag. I will make sure to account more for the lag in the future. Sorry. Okay, well, now that I've given you half the answers, I'll just keep going, and I will wait longer next time I ask a question for the chat. We're still adjusting to the tech, just like you are, so my bad. Okay, so things that are matter but not pure substances. Air is a mixture of mostly nitrogen, some oxygen, and then argon and a bunch of other stuff. So it's matter, it's a physical thing, but it is not a pure substance. A $5 bill is made of paper and fibers and various kinds of things. So that is a mixture. Seawater has mostly water, but also salt. And then also all sorts of other stuff is in seawater. So that's matter, but not pure substances. And then a diamond ring is a diamond plus, some metal that the diamond is on. So that is not a pure substance. And then the last thing is which things are not matter at all. So capitalism and chemistry are both sort of abstract concepts that aren't like a physical object. Chemistry, I think, well, both chemistry and capitalism, but they sort of talk about the real world and affect physical things. Chemistry is a study of physical things, but just sort of chemistry as a concept doesn't have mass, right? Okay. And then the next thing I wanted to talk about, well, I guess if anyone has disagreements or wants me to clarify any of these, I will wait 30 seconds before going on. Also, even if I have gone on and you realize you have a question, it's totally okay to still ask it. I'm happy to go back and clarify. So don't feel like just because I've, counted off my very scientific 20-second estimate for the lag, that doesn't mean your window of asking questions are closed. I always guarantee you that if you have a question, someone else does too. So yeah, even if we've moved on, please feel free to ask more questions. Okay. So the next thing is states of matter. So solid, liquid, and gas are the most important ones. You're probably sort of at least conceptually familiar with like what is a solid, liquid, and gas. But there are some things that are kind of on the border, and there are like somewhat technical definitions of the difference between solid, liquid, and gas. So a solid fully retains its shape and does not flow. A liquid is a fluid with a well-defined surface. So if you think of the most common one is water, there's like a clear surface where you can tell where the water ends and where the air begins, right? And it takes the shape of part of its container. So your water doesn't like fully fill your glass no matter how much water you add, but it takes the shape of however much space at the bottom of the glass it is filling up. And then a gas is a fluid that fully fills its container. So if you fill a container with a gas, the gas isn't going to just like fill up the bottom of the container and leave the top empty. It's going to spread out to take up the whole space. So those are the basic definitions of solid, liquid, and gas. And some things are really easy to classify, and some are a little more ambiguous. So as practice in your groups, classify the following things at the bottom here with what state of matter you would put them in. Like I said, some are obvious and some are a little more ambiguous. So I'll give you a few minutes to talk about it. Can you let me know in the YouTube chat if you feel like your group needs more time? It is totally okay to need more time. I am guessing randomly how much time I think you'll need, so. Okay, looks like a couple people need more time, so gonna wait another couple minutes. Okay, I'm gonna keep going and reveal the answers. If you want to just like take 10 seconds to finish your thought if you're speaking and mute yourself if you need to. Okay, so the way that I would classify all of these is as following. Some of these might be a little surprising. So ice cubes are a solid. There might be some liquid on top if they're in the process of melting, but the ice cube itself is a solid. A glass of water is liquid. At least the water within the glass is certainly liquid. A window made of glass is one that's kind of ambiguous. So if you have a window, it like feels solid to you. But actually glass flows really slowly over time. So if you go to really, really, really old buildings, you'll see that the windows are narrower at the top, thinner at the top than they are at the bottom. And that's because the glass has slowly flowed. So if you're being super, super technical, a window made of glass is actually a liquid. It just flows on a really slow time scale such that it seems to us physically like it's a solid. So that's kind of more trivia. I wouldn't expect everyone to know offhand that glass slowly flows, but this just to show you that everything is not always exactly as it appears. Molten lava, as it's flowing, is a liquid. It's flowing. Similar with Vaseline, it kind of holds its shape, but if you put a glob of Vaseline on the ground, it will sort of slowly flow. But lava can harden into rock, in which case then it becomes a solid. So that's what's called a phase change, as something is changing from liquid to solid, or from any phase to any other phase. And then for gas, the helium in a balloon is a gas. It fully fills the balloon at all times. And if you lower the temperature, the whole balloon shrinks. It's not that the gas just sort of falls to the bottom of the balloon, right? And then the air around us is a gas. It might have tiny solid or liquid particles in it, but it's a gas. It fully fills our room. So I'm going to wait just a minute to see if anyone has questions on any of those. And please feel free to ask questions whenever, not just when I have paused for questions. Just stick them in the chat, and I might wait until a good break to answer them. But please, as soon as you feel you have a question, just go ahead and ask it immediately. Okay, so someone asked clarification of why is a window of glass a liquid again? And the answer to that is because the glass flows over time. So on a time scale of an hour or a day, as I look at my window, it's not changing. But over a time scale of years, that glass actually does flow. So if you look at really old windows in buildings that are hundreds of years old, that glass will slowly sink, and the window will be thicker at the bottom than it is at the top. Why does glass slowly move is kind of actually a complicated question. So it's mostly because glass is not, the word for it is glass is amorphous. So solid materials can be in any number of configurations, but they can be, two common ones are amorphous or crystalline. So yeah, I'm going to answer what is an amorphous solid in a second. So a crystalline solid, though they're sort of really rigidly packed so that they can't flow. Amorphous solids you can think of as they don't have that rigid structure. So they might be, please interrupt me if I'm explaining this poorly. They might be sort of solid on a short time scale, but there's no rigid bonds keeping them from flowing on a longer time scale. So yeah, it totally does happen to car windows. It's just that by the time your window and your car has flowed a measurable amount, it has been 100 years and everything else about your car is broken too. So yes, that will happen. Your car window will flow over time, but it's just that the time scale of interest here is not relevant to a car because the car will have rusted and everything else will go wrong with it. Yeah. Cool. So the last thing I wanted to talk about today is properties of matter. So there are two main types of properties. Physical properties can be measured without changing the identity of the substance. So I can look at the substance and do some kind of measurement that doesn't actually change anything about the substance. So a good example of that is color. I can look at the wall and see that it is blue. I haven't changed anything about the wall by looking at it. Chemical properties refer to the ability of substance to be changed into another substance. So I can't measure a chemical property without physically changing the material itself. So if I want to see whether X material reacts with Y material, by doing that reaction, I've changed materials X and Y. That change might be reversible. We might be able to go back, but just by observing this change, the material itself has changed forms. And someone asked a question about, so is it due to the chemical bonds of the glass? And yes, we're going to talk later about the different types of chemical bonds. But yes, is the short answer. Okay, so for physical and chemical properties, there's also extensive and intensive properties. So extensive properties depend on the amount of the substance. You can remember that by the word extent means amount. So an extensive property depends on the amount of the substance that I have in front of me. So a great example is mass. If I have a big pile of stuff or a small pile of stuff, the mass will be different. Whereas intensive properties don't depend on the amount of the stuff. So if my wall is blue, no matter how big my wall is, it's blue, right? So both physical and chemical properties can be either extensive or intensive. Okay, so the last thing we're going to ask you to do today is in your small groups, define which of the following properties are physical properties, and therefore you're saying the other ones are chemical properties, and which of them are extensive, and which of them are intensive. Okay, so I'll give you probably won't have time to get through discussing all of these, but I'll give you just a few minutes to discuss them.
So I think we should answer that. What you do? Well, they asked. Oh, the log.
Okay, just in the interest of time, I'm going to reveal the answers to these. I'm sorry if your groups didn't have time to fully finish discussing them, but there are more practice problems on the problem set. So all of the problems that you did in your groups are part of the problem set, and then for all of the topics, there are more examples for you to practice. Someone's saying they still don't understand intensive properties and extensive properties. Maybe my showing you the answers to these will answer that question. If not, we can keep talking after class. Okay, so starting with physical properties. So mass, volume, density, and melting temperature I can measure without changing the identity of the substance. I put a substance on a scale. I haven't changed anything about that substance by putting it on the scale. I now know its mass, so that's a physical property. Volume and density are similar. Melting temperature is a little more complicated. We've changed the phase, but we haven't changed sort of the underlying chemical, we haven't changed what substance it is. But then rusting, reactivity, and then energy production by burning of gasoline, those are all physically actually changing what substance we have. And so those are all chemical properties. And then intensive versus extensive. So mass and volume and the amount of energy produced by burning gasoline, those are all extensive. So if I have more gasoline, I'll produce more energy. If I have, a liter of water versus 2 liters of water, that's a different volume and it will have a different mass. Whereas density, whether I have 1 liter of water or 2 liters of water, the density is the same. And what temperature it will freeze at is still the same. So I hope that kind of helps with the definitions of intensive and extensive. It is 11:45, so if you have to go, you're welcome to. That's all the material that we have for today, but I will keep the live on for a couple minutes if anyone wants to stay and has any questions. But you are free to go if you want to. The problem set for today is posted and is due tomorrow, and you can use those problems for practice. But yeah, please ask any more questions and email us if you have tech issues or anything we can help with.
Yeah, so what I'm going to do now is I'm going to close all of the breakout rooms and pull everyone back into the main Zoom call. So then from there, feel free to leave, or you can also stay if you have more questions, and Lorena and I will wait on to answer them for a bit. So I'm going to wait 20 seconds to do that just because there's a lag. Yeah.
Okay, so someone asked, can you please explain how matter is extensive again? Matter isn't really a property. Matter is like a classification of stuff. So I wouldn't say that matter itself is either extensive or intensive, but mass is extensive. So just think of it as if I have a glass of water in front of me, I can change the amount of water that's in that glass. So I can put in a cup of water or 2 cups of water. And when I do that, when I change how much water I've put into the glass, I'm also changing the mass of the glass. And so therefore mass is an extensive property because it depends on the extent, it depends on the amount of stuff that I am measuring the mass of. Yeah, so I guess someone asked, do I ask the questions on Zoom or YouTube? I wanted to give a few minutes at the end of the Zoom in case people had questions they wanted to ask in front of the whole class. But now I'm going to end the live stream and we're gonna be on Zoom and you can ask us any additional questions you have on Zoom. So thanks everyone, and we will see you tomorrow, or we'll see you in the Zoom call now if you have more questions.
Hi everyone, can you hear me?